Good evening, everyone. My name is Kim Cuomo, and I'd like to welcome you back to another Tech Talk in our series sponsored by Scismic. Today, we have the pleasure of welcoming Alex Greenberg to give us a brief talk about React hooks. So without further ado, I'd like to pass it over to you, Alex.
Thank you, Kim. So, good evening. And I would first like to thank Scismic for sponsoring this tech talk and all of you for joining me today for this presentation. Tonight, we will be discussing the popular front-end library React and some useful hooks released in the recent years. So some of these hooks you may or may not have experience with, and many of them which we will discuss tonight have been available since React version 16, which was released in 2017. And while they have been available for several years, thorough adoption is a slow process, and many times code bases will maintain current practices they have already implemented for consistency. With that said, React has come a long way, and there have been many solutions provided as hooks for items like global state management, memoization, rendering priority, and transitioning. And some of these hooks can be a game changer in your next project. But before we get into the hooks, we should first discuss the React architecture to better understand why it has become one of the go-to front-end libraries. Reconciliation is the algorithm which processes component elements into DOM rendered on the user's screen. And among other things, it's React's reconciliation fiber tree architecture that makes it so powerful. Now let's take a look under the hood to see how this is done and what differentiates React from similar front-end libraries like Vue. So React provides the consistent rendering of an unlimited number of components at a stable 60 frames per second, whereas a similar library like Vue would provide only 10 frames per second. React's time complexity for rendering this data is amazingly a linear O of n versus O of n cubed for similar architecture. This means 1,000 components only need 1,000 comparison operations, whereas traditional architecture of the same type would need about 1 billion operations. But how does React do this? So as of 2017, React uses a fiber tree architecture and heuristic reconciliation algorithm to focus on specific changes while maintaining stable elements where possible and prioritizing these changes based on urgency to reach the user. This allows for certain elements in state to be served first to the client and allow others to be rendered after or while the tree is idle. This frees up processing power to focus on what is most time sensitive and preventing unnecessary comparison and DOM operations for elements which do not require re-rendering. So when the page first loads, React assembles a tree of DOM elements to a node, which we then append elements to in order to develop a hierarchy component structure. This initial tree is called the current tree. When the page is first rendered, the current tree's elements are fed into the rendering environment. This environment transforms these elements into DOM operations needed to render the client view, prioritizes them based on the urgency of reaching the client, and ultimately serves this data to the user's browser, who can then view and interact with the application. When a user interacts with the page or state changes, React detects this by comparing the current tree with one containing these changes. This new tree is called the working tree. And once these processes are complete, the working tree becomes the new current tree, and this concept continues with only the elements containing changes being passed into the new rendering environment. In summary, by using a heuristic algorithm and RFT architecture, React is able to discern stable elements through unique key identifiers and comparing changes between the current and working trees. And this focus on specific changes while preserving stable elements and prioritizing these changes ensures efficient rendering by reducing DOM operations to smaller chunks, which in turn allows for a continuous update within 16 millisecond intervals, the necessary time frame to provide a smooth 60 FPS user experience regardless of the number of elements and operations. So now that we have a better understanding of React's architecture and how it works under the hood, let's get into some hooks. So we won't have enough time to cover them all or go into explicit detail for that matter, but we will go over some of the most useful and prominent hooks for state and form management, rendering priority, and transitional loading. Now, React has always been great for local state management, but as new versions have come out over the years, it has accrued helpful features for global state management. Now, you might be thinking, isn't that Redux territory? Well, yes. And Andrew Clark, the co-founder of the Redux, is one of the core developers of React and has helped bring them closer in capabilities with each new release. So for hooks, let's start with the tried and true favorite concept, memoization. React has implemented a hook called useMemo, taking much of the legwork out of managing expensive functions and computations. This hook allows you to run a function without the use of extra variables, state, closure, or helper functions, and return a cached value if it has already been invoked with that input. As we see in the code snippet, the syntax is very similar to useState and provides a dependency array for the value you want returned in the cache. Along with useMemo, React has provided the hook useCallback, which provides a similar feature for calling memoization functions. UseMemo allows us to return memoized values, and useCallback allows us to call memoized functions. Next, we have a useful hook for state management across components. In this slide, we see an example of props drilling. Now, while occasionally necessary in the past, it was never ideal to have data being passed through components that may not need it, and the deep tunneling could lead to bugs and added legwork for making changes to different components, always having to keep track of props and ensuring that they're reaching the desired component. React has helped abstract this problem away and bring its feature set closer to that of Redux with the release of the hook useContext. Now, on this slide, we see a solution to the same problem, but this time using useContext to pass data to components without props drilling. This hook has similar syntax to Redux in that we can wrap components in a provider tag linked to a piece of state, which can then be accessed by other components within the component hierarchy structure wrapped within this provider tag. This can be a game changer for state management, and while Redux has its use cases, hooks like this makes React's applications even more broad than it already is. So one of the great features of Redux is in its state management solutions is the concept of reducers. A reducer is a function that is able to manipulate state data in a desired way, specified by a desired action. Now, thanks to React's core development team, the library has the ability to use this concept through a hook called useReducer. We can now manage state easier by using reducer functions and specified actions to route the initial state data to the appropriate functionality. We can have a single function looking for specified action types, and when found, perform the desired functionality to our state. So for example, if we had a reducer function for a counter within our application, we can have this function look for actions like increment or decrement, and rely on the same functionality to perform different results based on the action type provided. This is a big advantage in modular programming and abstracts away a lot of additional logic that would otherwise be needed and promotes better readability and much less block complexity. Another feature implemented into React using the concept of actions is the hook useActionState. As we discussed in the previous slide, we were able to use actions to perform specific logic based on the action type provided. One area the concept of actions is very useful in is form management. Using a hook like useActionState can abstract away certain cruxes of handling form state data, and allows us to update a piece of state based on the result of a form. This allows us to automatically update state and re-render when a form is submitted, provide errors if there is issues with processing the request, and have the ability to provide a transitional label like pending if the form is submitted but the state has not yet been updated. This hook not only takes care of some of the necessities of managing form state, but also creates a smoother user experience, giving us the ability to provide concise feedback in the event of errors, or better managing longer loading times by rendering a transitional state like pending. As mentioned in the previous slide, for a smooth and optimal user experience, load times should be short and at least have some kind of dynamic rendering showing that the processes are still ongoing. React has implemented a feature to help mitigate the issue of long loading times and ensure the best user experience possible with a hook called useTransition. As we can see in the code snippet, the hook follows very similar syntax to useState and allows us to specify what should be rendered and how based on where the component is in the rendering process. We can start a transition in a click handler, and based on the length of the process, have pre-configured elements that will render or not render or change the labeling of something to denote the application is still loading. This can be a big help with user experience overall, especially for projects that require large amounts of data fetching or caching. The user cannot know if the requests have timed out or failed, so having a transitional render on the screen, even something as simple as a button label changing to loading, can be a big lift for your user bounce rate. So continuing on the topic of user experience, we move on to another hook implemented in recent years called used deferred value. This hook, similar to use transition, allows us to provide content or state despite the processing and rendering of these respective items not yet being complete. An example of this can be very useful in a project is if you were rendering a list of items being fetched from a database or API, and while the data is being fetched and state is being updated, we can allow the user to view, quote, stale material while, quote, fresh content loads. Despite the rendered content not being the most up-to-date, this consistent rendering can truly enhance an application's perceived performance, which in some cases is just as important as actual performance, since if the user doesn't stick around, there's no performance at all. So this hook can also be used to prioritize the rendering of components. And if you have a complicated chart or set of data, you may want to use a hook like use deferred value to delay the rendering of the chart until the rest of the component is rendered. And finally, the last hook we will review tonight, and yet another feature implemented in React to better manage user experience and loading time, is a hook called use optimistic. This hook lets you show a different state while asynchronous action is underway. It accepts a piece of state as an argument and returns a copy of that state that can be different during the duration of the asynchronous action, such as a network request. The state is called optimistic state because it is usually used to immediately present the user with the result of their performing an action, even though the action usually takes time to complete. Like some of the hooks we reviewed earlier, this is another efficient way of improving the bounce rate of your application by improving the experience of the end user. So that will be the last hook that we will cover today. And we'll move on to my works cited. And we can now open up the floor to questions if there are any. And if there are no questions, with that, I would like to thank you all again for attending this presentation and Scismic for sponsoring this talk.
Thank you so much, Alex. That was an incredibly informative talk. And thank you to all who came out tonight. We will see you at the next one.